Good afternoon. My name is Dr. Richard Goldfarb. I am the Medical Director for Factor Medical, the makers of Selphyl. I'm here today to go over the exact steps in detail so that you can prepare the kit in order to do a procedure on your patients. This is the kit that comes completely sealed. If the seal is broken in any way, please let us know, as this may or may not be a contaminated kit. Instructions are provided with each kit. The kit is complete with the red and yellow tubes, as Stacy is demonstrating. This is our 9 ml yellow tube. In the tube at the bottom is the separator gel, along with approximately 1 cc of sodium citrate, which is your anticoagulant. As you can clearly see, with the separator gel and the sodium citrate in this, you must keep the tourniquet on when drawing blood, because you must fill the tube to the max up to 9 ml for an ultimate draw of blood. It is paramountly important for us to get as many platelets as possible and plasma. This is our 9 ml collection tube. In the tube is our separator gel at the bottom with 1 cc of sodium citrate. It is especially important that when you draw the blood, that you keep the tourniquet in place. Many of you are used to taking the tourniquet off once you get a flash of blood in your collection tube. However, in our tube, it is very important that you keep the tourniquet in place in order to get more pressure into the tube in order to fill it at 9 ml because of the separator gel and the sodium citrate. You will be transferring the plasma and platelets through the transfer device into our calcium chloride tube. This is extremely important because this now reenacts the clotting mechanism. By doing that, this is what allows the matrix to form in order for the growth factors to be released over time and not immediately. This is incredibly important, and this is something that everybody must understand that makes our kit very different from any other kit that's out there. It is a closed system, no blood contamination to the person drawing the blood and or the patient. That's what makes this quite unique. The calcium chloride reacts on the clotting mechanism, so you will have a time limit in order to utilize the finished product. We are now going to demonstrate for you the exact mechanism in which we have to draw the blood for your patients, with all the details explained to make sure that you optimize the blood draw. As you can see, the tourniquet is placed, and Stacy is now locating the vein to be used. If you have trouble and the vein does not pop up, there are many things you can do. One of them is you can palpate the vein by gently tapping the area. You want to do that? Mm-hmm. In order to have the vein pop up. If you have difficulty in locating the vein, it may result in you having to take the tourniquet off and going to the other side. In rare instances, you may actually have to get a warm compress and place it over the forearm area. If all that does not work for you, you then may have to draw blood either in what's called the intern's vein over the wrist or actually from the hand. Stacy now has located the vein and is ready to do the venipuncture. She will get a flash back beyond the butterfly. If you do not see that flash, please do not engage the yellow tube. It is very, very important that you keep the tube in a dependent position in order for you to fill the tube. As you notice, the tourniquet is in place and remains in place in order to fill the tube. That extra pressure is needed because of the separator gel and the sodium citrate in the tube. You must continue to allow the blood to draw into the tube up to the yellow stopper. As you can see, the blood tube is filled. It is about 1/4 of an inch below the yellow stopper. That is more than adequate amount of blood in the tube in order for you to get a maximum yield. Please note that the tourniquet is still in place. At this time, she is going to remove the tube and place it on the table. Put pressure over the puncture site and then remove the butterfly. There is a safety mechanism which you can slide up over the tip of the needle. Stacy is going to demonstrate for you an adequate amount of blood in our 9 ml tube. At this point, she will invert the tube 7 times. Slowly. We don't want to create any bubbles. We want a mixture so that the sodium citrate mixes with the blood. Stacy is demonstrating an extra butterfly kit. I highly suggest that every office that is performing this procedure have a box of extra butterfly kits. The reason is if you start to draw blood and the butterfly itself doesn't draw the blood through the butterfly into the vacutainer tube, you're going to really need to, quote, troubleshoot. And the way you would troubleshoot is you would use this new butterfly and then draw the blood directly into a larger syringe. We suggest that in that case that you have a 10 cc syringe in order to draw enough blood. At that time, it would allow you to salvage the kit and not have to open a new one. You would then place a needle on top of the actual 10 mLs of blood and place it directly through the top of the yellow tube into the tube. If you are still in the vein and do not have enough pressure to fill our yellow tube, what you would do is disconnect the connector to the vacutainer, place on a 10 ml blood draw tube, and then you would slowly fill the tube with blood up to the 10 mLs. Once you would have filled the syringe with blood up to 10 mLs, you would then connect an 18 gauge needle on top of the syringe. The reason we use an 18 gauge needle is we do not want to disrupt any of the platelets in the transfer to the yellow tube. Once you place the blood into the yellow tube, do it very slowly and carefully. Once you are removing the syringe and needle, please be aware of the fact that the back pressure is going to perhaps splatter some blood. So I would do this over an area where it's protected and you are protected. So Stacy has inverted the tube 7 times. Because it's a 4 cc kit, we need a counterbalance. With your centrifuges come a counterbalance tube, also marked in yellow. This will counterbalance by weight the blood tube. Stacy now is demonstrating how you place the dummy tube into the holder and make sure that you place the yellow cap on top. She will now place the blood tube in the exact manner, and the tubes must be opposite when placed into the centrifuge. She then will close the lid, and once it is closed, the light goes on, i.e. the yellow indicator light will go on. She then presses the yellow button, and this will start the 6-minute spin at 1100 G. With 1 minute to go in the cycle, the green light will be flashing to let you know there is 1 minute left. Allow the centrifuge to come to a complete stop, and you will notice that the red light now lights up. You now can open the centrifuge top and remove your blood tube. The platelets are sitting just above the separator gel in the plasma. It is extremely important that you invert this tube 7 times in order to suspend the platelets in the plasma. It comes up several times about the concentration of our particular system. The concentration is the ratio of the platelets to the plasma. You can make this ratio any ratio you would like. If you removed some of the plasma, you can make this a 6, 10, 12 concentration. But the reality is you still have the same amount of platelets. So what's most important is the number of platelets that are in the kit. A complete inversion 7 times is very vital to the success in your treatment. Stacy has 4 1cc Loralox syringes. We use the Loralox syringes because they will fit onto the transfer device, i.e. a closed system is maintained. In transferring from the yellow tube to the red tube, it is color coded, except for the blue and yellow go together and the red goes to red. It is incredibly important that you do this in a vertical fashion and not in a horizontal fashion. We have found that puncturing the upper tube first will increase the pressure to the receiving tube on the bottom and will allow complete emptying of the yellow tube. At times, you have to re-engage the yellow tube in order to remove the remaining plasma and platelets. Stacy will then gently invert the tube so that the calcium chloride mixes evenly with the plasma and platelets. Do not shake, do not cause any bubbles to occur. Gently cause an admixture. Stacy will now place the Loralox syringe on the tube Turn it upside down in order to draw it into the syringe. As Stacy has clearly demonstrated, our yield is approximately 4 mLs. 4 complete 1 ml Loroloc tubes have been drawn. Stacy will now demonstrate how the needle is placed onto the Loroloc syringe in preparation for use in the patient. As you can clearly see on her working station, there is no blood contamination to the operator and to the patient. This closed system is unique to the Selphyl system. Please note that Stacy is drawing the finished product very slowly into the 1 ml tubes. We want to keep any of the bubbles out of it so that we have pure product. If the bubbles remain in it, you may not draw all the material out of the red tube. In that case, you would have to troubleshoot it by opening the top of the red tube with a 3 cc syringe. You can go down into the bottom of the tube, which Stacy will demonstrate. So we were not able to remove the entire amount of finished product from the red tube. Therefore, we are going to demonstrate how you can still get that product out of the tube. I suggest that you use a 3 cc syringe with a long 27 gauge needle. This will allow you, in one step, as Stacy's going to demonstrate, for you to remove the remaining product. This now becomes an open process as opposed to a closed process. However, it is more important that you maximize your yield. Please note how she is demonstrating that. I highly recommend that you obtain the 3 cc syringe with the needle already engaged. This allows easy removal of the remaining product from the red tube. This is our yellow tube. In the bottom, you can clearly see the separator gel and about 1 cc of sodium citrate. This is the anticoagulant. Please note that when you draw the blood into this tube, we must maximize the amount of blood in the tube. We want to achieve it up to about this level here. So let's say that you have drawn from the vacutainer the blood in this tube and it only filled halfway. You must then take a new butterfly and a syringe, draw remaining blood, and then transfer it through the top to fill the tube up to this level. Please note that by pressurizing the blood and placing it externally in this fashion, the separator gel will have an abundance of pressure on it. You will then get a little bit of leakage of some RBCs going through to your final product. This is inconsequential to the final result in which you're trying to achieve. If it is clearly bloody, you cannot use it. But if it is slightly pink tinged, it is absolutely fine to use. I have used it several times in that fashion. Please note that it is not a tube that you need to throw away. It is still going to work and operate perfectly well for you.